Okay, hey everyone. I am Greg from ENS Labs, and today we're going to be talking about ENS and bringing identity into your apps. So the general agenda is first, what is ENS? Why is it important? What are the different types of names? How does it work under the hood? And then finally, some resources to help you build on ENS this weekend. So first, what is ENS? The Ethereum name service is a decentralized, permissionless naming protocol that lives on Ethereum and scales to the entire internet. It turns complex hex addresses into human-readable names. So obviously, the top is what we're used to, but generally not a good user experience in any application. And then what we turn addresses into, nick.eth, is a human-readable name for blockchain addresses. So similar to the way DNS improved the user experience of the internet by going from IP addresses to human-readable names, ENS turns crypto addresses into human-readable names, which is even worse than IP addresses. So the end goal is that anywhere you read or write in a crypto address, you should be able to use an ENS name instead. And so what does that actually look like? On the left-hand side, you can see a list of past transactions of Luke.eth sending something to GregScroll.eth. And that's just very understandable. You know, it's human-readable name to human-readable name. Whereas underneath that, we have GregScroll.eth sending something to a random address. And if you just look at it, you have no idea what this is actually doing. There's no context in the transaction. And so ENS brings context and, human-readable names to crypto transactions. And then on the right-hand side, you can imagine the send flow. So this is me in MetaMask sending assets to GregScroll.eth, which is infinitely easier than just copying and pasting an address, potentially copying the wrong address or typing it in incorrectly. It's safer, it's better, and this is all powered by ENS. So those two things are powered by basically two different sides of ENS, right? So on the left side, I'm not typing in the name, it just shows up based on the address. And so the first format of resolution is forward resolution. So that's when I type in a name and it looks up the address for that name. Any number of names can point to the same address, but an address can only reverse resolve or have one primary name. So OX, B8, and so on, this will always be nick.eth. It can only have one primary name, and that's reverse resolution. So there's forward and reverse. Reverse resolution is also what we call primary names. And this kind of leads into ENS being a profile more than it is just a username. You'll notice all these websites in the bottom. If you go to that website / my ENS name, it's really just my on-chain profile. It's this portable Web3 profile. And to lean into that a little bit more, you can see that, yes, this is my name, GregScroll.eth, but also there's a ton of metadata attached to it. And so really think about ENS as your portable Web3 profile, your Web3 identity. And that really goes with you across different apps in the ecosystem. So this is snapshot.org and matcha.xyz, two sites that are not built by ENS or ENS specific, but when I sign into them with my wallet, they recognize me as GregScroll.eth. It's my portable identity coming across Web3 with me. Cool. Now we understand what it does and maybe why it's important, but just to be extra clear, the North Star is that users of crypto-powered experiences should never have to interact with a hex address. And I'm going to tell you a funny story that actually happened. I did this little side project called Good Bread by Greg. I enjoy baking. And my mom was telling her friends about it, as moms do. And one of her friends wanted this NFT that I created because they thought it was cool. I think it's cool too. But anyways, she basically texted me, my mom, saying, Caroline wants your NFT. How can she get it? And I said, send me her wallet address. And the thing she sent me back was actually an ENS name, caroline1.cb.id. It was a different name, but it was something 1.cb.id. And so I was like, oh, that's cool. That's exactly what ENS is. That's what we're building. And the takeaway here, it might seem obvious, but it's like I asked for an address, and most people don't understand what addresses are. They just want human-readable names. And so this person, Caroline, that onboarded it into ENS, or onboarded it into crypto, never had to deal with a hex address. And this is really the experience that we want people to have when they're using crypto products. Cool. And just to emphasize that, this is the Ethereum logo as you all know it. And the ENS logo is actually designed to be a wrapper around Ethereum because it improves the user experience of Ethereum. So what are the different types of ENS names? Most people think it's just .eth, but as you saw on the last slide, there are cb.id names as well. And cb.id isn't just a new thing in ENS. it is a DNS name. So within ENS, you can use .eth names. That is kind of our native on-chain, most decentralized TLD. That's the only ENS specific TLD. And then we also respect any DNS TLD. So this is a .com, a .id, .xyz, and the list goes on. And the reason we do this is because ENS respects existing internet infrastructure. We're not just going to go and create a bunch of different TLDs. We have one native on-chain TLD, and otherwise we allow you to use any DNS name. And there are some differences between these. At the end of the day, they both work the same. You know, my mom sent me caroline1.cb.id, and I was able to find the address. That's kind of the core functionality, and that works across DNS and .eth. But just to point out the differences, .eth lives on mainnet Ethereum today. It's fully decentralized, owned and controlled by ENS DAO, and there is an annual fee to make sure that these names are used and not just kind of sat on for the sake of squatting or anything else. Whereas to use DNS names in ENS, there's actually no ENS fee at all. You can do this completely for free. And the belief here is that you already pay a fee to register the DNS domain, so we're not going to make you pay again. Really, the goal of ENS is to have a healthy namespace and for people to actually use human readable names. And so it's not about charging for those names, it's about keeping a healthy namespace. And here, it's less decentralized. Ultimately, the owner of the DNS name is the owner of the name in the ENS ecosystem. So if your domain registrar or something chooses to take your domain away, which has happened, then you would lose the name, which is not possible with .eth. And so different trade-offs, but ultimately, these are your options. And for both of those type of names, .eth and DNS, you can have subdomains in a number of flexible ways, namely off-chain. And so if you've been on crypto Twitter recently, you may have seen base.eth names, linea.eth names, and all of these are actually built on top of ENS. To build subdomains, there's no protocol fee to ENS, and it is the ultimate flexibility in terms of building your own namespace. It's made possible by CCIP read, which I will explain more in a second, but basically allows you to build subdomains in any flexible way. And now there are more subdomains in circulation than there are regular domains, like .eth names. And we love that. You know, your app can have its own branded subdomain, and it's free for you, and it's a good experience for your users, and everybody wins. So, how does ENS work, including subdomains and everything else? Oh, I guess this looks kind of funny with the lines on the TV, so apologies if that's confusing. But basically, the ENS registry is a smart contract on mainnet Ethereum. This is a simplification, but it stores a name side by side with a resolver. A resolver is what actually controls where the data is stored in a name. And multiple names can use the same resolver, or they can use their own resolver. And you'll see in a second, that is how some of these custom subdomain experiences kind of work. So I, gregscroll.eth, use this resolver, which we call the public resolver. It's basically the default contract. If you go to ens.domains and register a name today, you will use the same resolver. And what it allows you to do is store a bunch of metadata associated with a name. And so again, an oversimplification, some of this stuff is actually encoded in the smart contract, but basically you can store any address for any chain. So another misconception is that ENS is only for mainnet Ethereum, but that's actually not true. You can store a Bitcoin address on an ENS name and then go to PayPal and send your Bitcoin from your PayPal wallet to any ENS name. And similarly, text records allow you to store any arbitrary key value pair attached to an ENS name. And so this is what I was showing before with a profile. I had an image, that's the avatar record. I had a little bio, that's the description record. And so there are kind of like common ones that we recommend people use, but you can also use anything. And so imagine you put some encryption key or some extra profile that's specific to your app, some extra metadata. This is the perfect place to put it because it travels with these portable Web3 profiles. And then lastly, there's this idea of a content hash, which I can get into if anybody has questions on it later, but it's basically a way to build decentralized websites on ENS. And I'll kind of just leave it at that for now because we have other things to cover. So that is the public resolver, but there's also special types of resolvers that we generally call off-chain resolvers. And you'll notice these look different because they actually revert with an error, an off-chain lookup. And this is what is CCIP read, like I explained before, and in combination with an ENS IP, which I'll also explain in a second. And high level, what this does is basically defer the resolution process to some off-chain gateway. So whereas this just looks at internal contract storage to determine that my ETH address is OX179A and so on, this will then look at an off-chain gateway, and that off-chain gateway can either read that data from a database or a layer 2 or anything else. And this is how kind of cheap, flexible subdomains on ENS work. What ENS IP10 does is basically wildcard resolution. So if a name doesn't exist, that's what the star is. So like greg.cb.id, that doesn't exist in the ENS registry. And so what the wallet will do, if you go into type greg.cb.id, will try and basically resolve that full name through the resolver of cb.id, which is OX1934, so on. And so that's powered by ENS IP10. And then CCIP read is that deferral process that I explained before. So the wallet will basically go to the resolver contract. It will ask for the address. That contract will revert with the CCIP read or with the off-chain lookup. And then the wallet will go further to get the data from the off-chain gateway. It will be verified in the contract and ultimately returned to the client. This all happens transparently. And so as a developer, you really don't need to worry about the details. You kind of just take care of the gateway, and then the rest is built into Ethers and VM and WAGMI and all those things. But just important to know, and I think a cool thing to understand. Also worth noting, this is an EIP, not an ENS IP. So CCIP read can be used in any application outside of ENS as well. Okay, we also have this thing called an EVM gateway resolver, which is effectively the same thing as off-chain resolvers, except the callback function in CCIP read is a little bit different. And so I can explain that if you want, but the goal of this is to have trustless L2 subdomains. So you have a smart contract on a layer 2, which basically mints your subdomains, and that's up to your own implementation. And then on mainnet in the resolver, it will verify that that's true based on the L2 state root that's posted to mainnet. So I know I'm kind of skipping over this, but ultimately what I'm trying to get at is CCIP read is very flexible in combination with wildcard resolution to build any type of subdomain experience that you want. And this is exactly how linear.eth works, for example. Okay, that is what is ENS, why is it important, generally how it works. Now, how to build on it and kind of what we're offering this week. So if you scan this QR code, and I'll show it again later, so okay, if you skip it for now, we have a list of kind of code snippets and examples and links to docs and resources of basically learning more what I just said and answering any common questions. For building on ENS this weekend, we have 3 different prizes. One is for the best use of ENS in a consumer application with account abstraction. So say you're onboarding users to an application with some wallet that they don't really understand as a wallet, that's abstracted from the experience. Oftentimes, these experiences will have a username or a profile of some sort. And so building that with ENS makes you eligible for this prize. And the next, there is $1,700 for the best use of ENS in a privacy-centric application, which I'll give you an example of in just a second. And then $500 for 3 honorable mentions that just build something cool with ENS. An example of what won our highest prize last year is FluidKey. And these guys will be here this weekend as well. But they built basically stealth addresses on ENS. And the way it works is gregsquirrel.fkey.id is an ENS name. You can type it into MetaMask and so on. But every time you type it into MetaMask, it will return a different address. Ultimately, I have control over all of those addresses, and they get aggregated into this one basically dashboard below where I can use the funds. But it's a way to use an ENS name and receive funds privately. And we thought that was really cool and won our prize at ETHRome last year. So excited to see what people build. Obviously, this is just inspiration. Don't try and clone it exactly, but hopefully that gives you some ideas of what you can build. So that's what I have for you. I think we have time for some questions. Here's that same QR code again. If you want to scan it, it will also be by the booth all weekend. But yeah, any questions? Okay. Yeah, Lamone. Yep.
With a subdomain that is issued by, let's say, on base or on base logins. Does it subdomain ENS there will only base can I use the money.eth and resolve it also on base?
Yeah. So the question was basically, I think the question was, does the network have to implement something so that you can use this EVM gateway resolver, or can you do it on your own? Is
That's the mostly, and then let's see the example with linear.
Yep.
Why should I use linear.eth instead of why should I use the money.linear.eth and not like the money.eth?
Okay, got it. So yeah, the question is like, first of all, what I said before, and then why would you use something.linear.eth instead of your own name? And I guess I'll start with the first one. The networks don't have to deploy anything for you to do this. We have gateways across a number of networks to like do this out of the box. And so the network doesn't have to deploy anything specific. You can actually roll everything your own. And links to those docs basically are included in this QR code. And we'll be by the booth to help you out. So you aren't limited to a specific network. You can do it on Base. You can do it on any OP stack chain and a number of others as well. And then the second question of why would you use a subdomain instead of a second level domain is what we call it. And the answer is like, you don't really have to. You know, I have gregstroll.eth. That is what I use across all the apps as my identity. I think what's powerful about subdomains is, first of all, branding for applications. And so like within the Linea ecosystem, maybe they put preference to the Linea.eth name instead of your lemone.eth name. And also a lot of users, if we're talking about onboarding new people to crypto, don't have a .eth name. And so it's like, if they don't have any name, then it's better to give them a subdomain that could be cheap or free than basically expect them to already have a .eth name. So a lot of these things I think are useful for onboarding rather than people that already exist in Web3. But generally, those are the two ways I think about it. Oh, we got one question in the back.
Is there a way to play with this, like, without mainnet or testnet, no net, something like that?
Yeah, the question was, for the recordings, is there a way to use ENS on a local DevNet, basically, instead of a deployed testnet? Technically, yes, but it will be a lot easier to just use a testnet, I would say. Cool. I think that brings us to time. So appreciate everybody for watching, and come by the booth if you have any questions.